Okay, let's get right into it. We're about to break down a wave so incredibly tall, it almost seems impossible. We're talking about a literal wall of water that moved nearly as fast as a jetliner. And the craziest part? The whole event, from start to finish, took less than 4 minutes. 1,720 feet. Let that sink in for a second. That is the official height of the tallest wave ever recorded by humanity. It's a number so massive, it's honestly hard to even picture without some real-world context. So let's get that context. Take a look at this. That wall of water was over 5 times taller than the Statue of Liberty. Just try to imagine standing at the base of the statue and looking up at a wave that high. It's mind-boggling. Now, you probably think that for a tsunami to happen, you need a gigantic earthquake way out in the deep ocean. And you'd be right, most of the time. That's how about 90% of them get started. But the single tallest wave we've ever documented, it didn't need an ocean quake at all. All it needed was gravity and a mountain that was ready to fall.
It all comes down to a really simple idea from physics called displacement. Think about it like this. It's the exact same thing that happens in your bathtub when you get in or drop something heavy into it and the water level rises and spills over. Except in this story, this something heavy was 90 million tons of rock.
So let's go back in time. The place is Lituya Bay, a remote fjord in Alaska. The date is July 9th, 1958. The time is just after 10 o'clock at night. At 10:15 p.m., it's a calm, clear night. 3 small fishing boats are anchored peacefully in the bay. Then, just seconds later, the ground starts to shake violently. It's a massive magnitude 7.8 earthquake. And for the next 13 seconds, the nearby Fairweather Fault tears open. But the earthquake itself wasn't the real danger, no. The real danger was what it had just shaken loose. An entire mountainside, 90 million tons of rock, ice, and dirt was instantly fractured from its slope. It then plunged more than 3,000 feet, falling as a single solid mass directly into the narrow inlet at the head of the bay. And this is the exact moment when the physics of the situation becomes absolutely terrifying. This is how an ordinary mountain turns into a weapon of unbelievable power. That impact unleashed a colossal amount of energy into a very small, confined space. So how did this all unfold? Well, it really breaks down into 4 distinct steps. First, you have the impact. 90 million tons of rock slams into the water. Second, displacement. All of that water has nowhere to go but straight up, creating a giant column into the air. Third, the splash. That massive column of water immediately collapses under its own weight and has only one direction to go, blasting straight across the narrow bay. And finally, the scar. The wave hits the opposite mountainside with so much force that it strips away every tree, every bit of soil, all the way down to the bare rock. And you just can't talk about this without understanding the sheer speed involved. Scientists estimate that water was moving at 500 miles per hour. To put that in perspective, that's nearly the cruising speed of a Boeing 747. There is simply no outrunning something moving that fast. So let's put that number, 1,720 feet, into perspective one last time. It's more than 5.5 times the height of the Statue of Liberty. It's 1.6 times taller than the Eiffel Tower in Paris, and it would have easily washed over the very top of the Empire State Building. And this all happened in less than 4 minutes. But you know, this isn't just a story about physics and geology. It's a human story, because there were people there that night, 3 boats anchored in the bay, whose occupants became eyewitnesses to an event that, by all accounts, should have been impossible to survive. On a boat called the Badger, you had Bill and Vivian Swanson. On the Edgery, there was Howard Ulrich and his 7-year-old son, and on the 3rd boat, the Sunmore, was a man named William Wagner.
Wagner was anchored closest to where the landslide hit. He saw it coming, an impossible black wall of water and trees rushing towards him in the dark. He did the only thing a sailor could do in that situation. He fired up his engine and pointed his bow directly into the face of the wave.
William Wagner and his boat were never resurfaced. Incredibly, the people on the other 2 boats actually survived. The Swansons and Howard Ulrich and his son were caught by the incredible surge. Their boats were lifted up and carried, like surfboards, clear over the spit of land at the mouth of the bay and out into the open ocean. And both parties later reported the same terrifying sensation. As one survivor put it, the wave didn't feel like water, it felt like concrete.
So,
Okay, why does this story from over 60 years ago matter to us right now? Because the most crucial thing to understand is that what happened in Lituya Bay was not a freak accident. It was a pattern.
In fact, when geologists studied the area, they found clear evidence that mega-tsunamis had happened in this exact same bay before. There was a nearly 400-foot wave in 1853, another one almost 500 feet tall in 1936. The specific geology that created the 1958 wave is not unique at all. And this is not just some remote Alaskan problem. 310 million Americans currently live within 50 miles of a coastline, and scientists have identified dozens of other potential hotspots all around the world, from Norway to New Zealand, that have the exact same kind of geological setup, just waiting for the right trigger. So here's the practical takeaway. For a wave like this, the warning sign isn't a siren, it's a sound. Survivors described an unmistakable roar, like a freight train or an explosion. If you're in a narrow bay or fjord and you hear that after an earthquake, you have to elevate immediately. Not inland, but up. Get to the highest ground you can as fast as you can. And if you're on a boat, you do not try to outrun it. You do what William Wagner did. You point your bow directly into the wave.
Now, the National Oceanic and Atmospheric Administration, or NOAA, does have real-time monitoring for some of these at-risk areas. You can actually sign up for SMS alerts at tsunami.gov. But here's the thing, the required response time is less than 3 minutes from the moment you get that alert to the moment you take action. The real key is knowing what to do long before an alert ever comes.
And finally, if you thought a massive wave trapped inside a bay was the absolute limit of the ocean's power, what do you think happens way out in the open sea, where there are no walls to contain the energy, and where multiple waves can stack on top of each other, combining their power into one?
Well, this coming Thursday, we're going deep on the Draupner Rogue Wave. It's a mathematical impossibility that was recorded in the North Sea, a monster that literally broke the laws of physics and proved that every sailor's worst nightmare is very, very real. I'll see you then.